Hi, this is Dr. Obulakonda Reddy, CSC Cybersecurity Department. Today we will discuss on traditional data center in high performance computing, in cloud computing. Now see here, traditional data center in cloud computing. So in a cloud data center, simply short form to write as a DC, cloud data center. Like in the right side diagram, you observe that this is a cloud data centers. In traditional data center, cloud data centers. Here now traditional data centers and cloud data centers. We observe the difference. These two. What is the traditional? What is the cloud data centers? Coming to the first parameter, we take as a servers. Now in a traditional data centers, it is a co-located dependent failure. And coming to cloud data center, it is a integrated fault tolerant. And second factor we take as a second thing. Then in coming to traditional data center, it is a partition perform interrelated. And coming to cloud data, it is a uniformed performance isolated. And the third thing is a management. That is a traditional data center as a separated manual, and cloud data center as a centralized full control with automation. It is centralized full control with automation. And coming to the scheduling, a plan head over provisioning, and it is a flexible scalable, flexible as well as the scalable. That cloud data centers. Coming to scheduling, scheduling in the sense it has to be a resources allotment one by one, like first time, second, third, fourth, and so on. And renting. Coming to the other factor is the renting. It is a traditional data center as a for physical emissions, and a cloud data center for logical usage. How much usage we can done in a data center. And application, coming to the other factor as application and services. Then fixes on designated servers, which has traditional data center as fixes on designated servers. But coming to cloud data center, it is runs on moves across all virtual machines. What are the requirements for this one? Cloud data center. This is indication to data center requirements. On demand self-service. The requirements are on demand self-service and resource pooling. We have to collect different resources at one places here. Now we observe that in that one it has to maintain with a large storage area. In that one it has to maintain storage area, different computing servers and storage areas. Something it is maintained. Resource pooling. Different resources are collected into a DC. DC means it is a data center. Now, so it is a resource pooling is one of the important thing, and rapid electricity. It has to be rapidly, it has to be increases. If it needs some more sizes, it is available to update the size also. And measured usage. So how much of resources, how much of usage done in a data center. Still how much space is the required. Then broad network accesses and network dependent. So it has to provide it with a broad network access and network dependent also. So these are all the some points important about the traditional data center and cloud data centers. These are all the different parameters compared with the traditional and cloud. These now observed here. So different here right from left side also we can see here now the typical elements in a warehouse scale systems. One unit server left. This is servers we have to maintain. This diagram has to be depicted with explain that it is a warehouse large scale systems. And second thing is 7 rack with Ethernet switches and diagram, small cluster level with Ethernet switch at the right. So in the middle we observe that rack with Ethernet. So we have to provide it with Ethernet, net providing services. Rack with the Ethernet services for networking purposes. We have used with Ethernet. That is the middle thing. And right side is a small cluster with it is a cluster in the group of server racks. So cluster switch. So now group of systems, it has to be a whole here. It has to be maintained now. So different systems. Small cluster with a cluster Ethernet, switch or routers. With the use of a switch and routers, it has to connect it with all systems here. So different observed here. In the right side, we have to various. It has to maintain the large systems are connected here. And then second thing is the Ethernet switch. And the middle, we have to maintain track with the Ethernet switch. And coming to the here now, this is a cluster level, like group of systems are connecting here. Cluster level, Ethernet switch are routers. Ethernet, different Ethernet and switches. Routers, the duty of router is providing route to a different packets. Now, so this is one of the diagrams here. And this is the important thing, whole DC data center, cloud data center, which has to hold all these components. Now observe here, from coming to here now. So here first individual allocation computer cabinets. So this is individual computer allocation cabinets. So the cabinet requirements of this is a size as to be mentioned that, and the typical capacity of 1750 to 3750 watts per cabinet. Next, so and other thing is a computer air conditioning unit, CRC, C-rack. This is a part, it is a C-rack which has to hold here now, C-rack, that is a computer air handling unit. And third one is a power distribution unit. So totally which has provided distributed to all these systems has to be produced with a power. Now this is a power distribution unit, PDU. And next one is a co-location chutes. So these are the co-location chutes, and these are all the heat rejection devices. Whenever the DC emission is very high, whenever the load will on computers, the heat will produce it. So it has to heat rejection devices. So sometimes whenever the computer are heat, these devices has to be reduce the heat in a DC. Okay. Then next thing is a pump room. So this is the pump room. And next thing is the electrical primary switchgear and a UPS system. This is a UPS system. This is a electrical primary switchgear. And these are the fuel storage tanks. This is a fuel. Whenever the power fails, then automatically it has to hold with a fuel capacity. And then next one is the emergency diesel generator. Whenever the power fails, immediately we started with a generators. So these are all structure of a data center, cloud data center, which has whole like this, all components. This is a overview of data center diagrams. Now, clusters of commodities. So current cloud data center achieves high performance using commodity servers and switches. We have to use combination of different servers at one place. We have to reach with a high performance. No specialized solution for supercomputing. And next thing is supercomputing still exists. Is an example of symmetric multiprocessing server. That is a symmetric multiprocessing server which hold 128 core and shared RAM. Okay. And other thing is compared to 32 4-core LAN connected servers. And accessing global data is SMP 100 network systems. LAN has 100 US systems. And next thing is computing penalty from delay LAN access. Performance gain when cluster grow large. Performance gain when cluster grows large. This one, the execution time versus number of nodes. Execution time versus number of nodes. If it is increase the number of nodes on AI cluster computing, what are the performance? So here indicated F is indicated as the global data input output in 10 microseconds. So approximately global data for input output. I is will taken as, for example, F will take as a global data will take F will take as a 100, and the medium will take as a 10, and low will take as a 1, 10, 100. Like low, medium, and high. Low, medium, high. We have to take with a 3 levels here. So based on this, how the performance will indicated to here. This is a server cluster and single high-end servers. We have observed here high communication, medium communication, light communication. The communication, how it's provided. So 1 to 10. What is the performance here? 1 to 10 scale. In the x-axis, take for number of nodes, and y-axis will take as a normalized execution time. How much time will take? So time versus nodes. Here the number of nodes in the x-axis, number of nodes, and this axis will take as a execution time. So what is the performance will given from the here. So systems are increased now. In the initial stages, the 0 to 4 means it may be 1 point, 1.23 like that. 1 point, how the performance will given. So this is a light communication. This will provide with the medium, and then it is providing with the high communications. So this is the performance execution time versus number of nodes in a high performance computing in cloud. Performance advantages versus performance versus cluster size. If it is cluster size will increases, what the performance indicates. So high communications we observed here now. So this is number of core processors at a performance advantage in a cluster. Cluster means a group of similar systems are connected together and work finally to get as a high performance. Now here now the performance usage is a cluster using the high-end nodes. The percentages we consider 10%, 5% like that. The systems are 500 systems are grouped into one cluster. So what is the performance? Light performance, the difference we observe at light to medium, medium to high. And the performance goes at 500 to approximately 10,000 systems, 1024. So what is the performance? The gap will the gap will reduce. The graph will observe here. The performance graph will be decreases. Now in the 2000 system 2048, the gap will also somewhat it has to be reduced. Coming to 4000 systems, approximately just a minor differences in between all will have to 5 to 10 scale only. But the medium will take as a 5 to 15, and 512 systems will take clustering system that may be a 0 to 30. The gap will have to observe here. The gap will reduce here in between high to low, low to high. This is the performance advantages first. Cluster size has to be increases. The performance will be a minor, minor we are observed in this graph. Now here the compare the performance building cluster using 128 core SMP single multiprocessor system versus 4 core simple multiprocessor. So more performance gain under high communication scenario. A cluster size grows, performance advantage is small. So the cluster size grows. So 4000. The performance advantage is a small. If it is a lesser number, it may be a gap is the communication gap is there. So it may be a large. But the cluster size grows. 4000 systems. Observe that 4109 systems. The scale point 0 to 5 only approximately all high performance, low and high, medium and light communication all in a small 1 to 5 scale. So which higher cost of 128 code only 5% performance advantages. Is it worthy? A DC wide systems. It is a data center wide systems. It is a software system consisting of this is a distributed system. Logical clocks, coordination and the logs, remote procedure calls, which has to maintain in a software systems in a DC machine. And distributed file system is also maintained. And parallel computing, which is used MapReduce or Hadoop. And next one is a virtual infrastructure, virtualized infrastructure. Now coming to the computing, VM or hypervisor. The hypervisor is a controlling of virtual machines. Just it is accelerated of hardware and software of a virtual machine. Now, so storage. What is the storage here? Virtualized or distributed storage. Network. And the network virtualization is the next step. Coming to here, MapReduce procedure. For example, if you take as a 100 terabytes data sets, if it is scanning with the 100 terabytes data sets in one node, that may be take as a 23 days. Now coming to a cluster systems, on 1000 nodes, it may take for a 33 minutes, it has to be completed. So that is the advantages for a MapReduce. MapReduce means it is mapping with a different total document has to be divided with a 3 categories like so here now MapReduce. So it is a map and group by key reduce. This is a mechanism to apply in a MapReduce. Now coming to here, so 100 terabytes data sets will scanning in one node. 23 days, one node it is computed with a 23 days time to take for that scanning the 100 terabytes. But coming to 100 nodes group into a clustering system, that has 33 minutes, approximately half an hour. It has to be completed with 100 nodes combination. That 100 TB data sets has to be completed. Single mission performance does not matter. So now what is it? Just add more. But how to use so many clusters? How to make a distributed programming simple and elegant? Now sounds great, but what about MTBF? Now MTBF again, mean time between failures. So mean time between failures. So one node equal to once per 3 years. 1000 nodes, one node per 1 day only. So that is a MTBF, mean time between failures. So one node, that may be once per 3 years. One node, if it is calculated with one node, that may be failure chance may be a once per 3 years. But coming to 1000 nodes, one node for 1 day only. So that load, that much of load has to be used in a 100 nodes in a clustering environment. Now map reduce refers to both performance for programming framework as well as the fault tolerant runtime. Now see here, map reduce word counting. The big document, the document has to be divided as a four categories. This is use the map reduce mechanism. Then here provided by the programmer, the map provided with a programmer. So it is reads the input. It's a reads input and produce a set of key value pairs. This is a map mechanism. Reads inputs and produce a set of key value pairs. And reduce is one of the mechanism. Collect all values belonging to the key and output. What is group by key? Based on the group, it has to be taken with a key. So now collect all pairs with a same key. So this is the three things. This is the map. This one is a reduce. In between group by key only. So this is a mechanism. Only sequential reads. Now the total big document has to be divided with a first apply to map. So it has to take key value pairs. It reads the input and key value pairs. So key is like this. This is a value. Key value like this. So total document has to be divided with key value pairs. And second thing, based on the group by key. So collect all pairs with the same key. Same key means it is a 1. So same 1. How many keys is that? Same name. So now same name with a different. Like this is the thing we consider with a group by key. Same name. Collect all pairs with the same key. And reduce is collect all values belonging to the key and output. So now key. So what is the output? Space. What is the output? Then like this. So this is a map reduce mechanism. Key value. Everywhere we have considered with a key value, but the mechanism will be different like that. The total big document has to be divided initially like this. Key value pair. Again, it has to be same group. Group into one category. Based on collect all pairs with the same key. Later, it has to produce with a collect all belongs to the key and output. So next thing is, so this is again explanation about same thing, big document. The big document has to be as considered as the input. Then that is given with a map. M is indication as a map. Then it has to be intermediate stages, group by key. So this is a stage we have done with a group by key. That is shuffle and sort. Now what are the keys in a map? K1V, K1V, K2V like this. So it is based on key value pairs. Map will find it. After that group by key same. Now it has to be grouped. Like what is the K1? K1 will contain values as K1 with a all V, K2 V, K3 2 V's, K4 V's, and K5 is also V. Based on the keys, same keys, it has to be a form. That is the group by key. Next thing is after that R is indication to reduce. Then reduce key with output. It has to produce with the reduce stages. That is collect all values belonging to the key and output. Key and that output has to be produced. In a group by key, collect all pairs with the same key. Same key, like key is a K2, what is it? K3, what is the values? Like this. So this is a map reduce overall diagram. Now, distributed execution overview. Like user here, the input data has to be split into a 0, 1, 2 like that. The document has to be divided with a n number of split. It has to be divided. It has to be given with a worker. Worker means it is a system has to perform here. No? Read the worker. So user diagram, user program. Created a fork. Fork is a small program which is run at operating system. So now fork, which is used at a mostly in Unix environment. Now the user program that assign a fork to worker, the worker will take a one split of big data, data. and the second worker will take as a 1 and the third worker will take as a 2. Like this, the workers, a small, 4 means it is a small task assigned with a operating system that will be given to worker. So it has to be run. The user program has to be a monitoring with a worker. So how it has to done it. Local write. In your local write, a remote read and sort, like shuffle and sort. This is the second stage. What is the second stage in map reduce? That is a group by key. So that is done in a group by key like this. This is called initial stages map. This one is a reduce. Now, so here now the user program, we created fork, 3 or 4. It has to monitor the all workers. The master is also observer controlling the how the worker will work here now. So this is assigned for map. This is for reduce, in between local write. So now this is the way we have to perform distributed execution overview. The master also deals with the master. The role of master will also deals with worker status updates. What is the worker up to what point he has done? What is the fault tolerance? Is it doing any fault in that workers? IO scheduling. So what are the one process has to be completed. Again, it has to be given schedule to other process. Then automatic distribution, one by one it has to be given, and automatic parallelization. So one has to be completed parallelly. So number of tasks as given at a time, it has to be distributed with different systems. So finally, it has to produce with a final output 1, output file 0, output file 2, like that. So this is the references collecting with this talk.
Like, share and subscribe. Hit the bell icon for more updates.